Well, welcome everybody. I'm going to start this new channel off. So today, I got permission to start doing this at my work. So today we're going to be building a blower for 8V-92 Detroit. So as you can see, I got some of the parts clean here, and we're going to start the construction on some of this slowly but surely, piece by piece, and show the people how it's done. I did not have any footage of tearing this one down because I did not have the permission at the time to do such a thing, as for the video. But as for going back together with it, and from here on out, I'm going to start doing videos of different components: blowers, water pumps, fuel systems, Caterpillar Detroit items, and whatever comes through the door. This is what I do. I also have the YouTube channel Digging Louisiana. If you get into metal detecting, I started that one up, and it seems to start to take off in the last few days. Today is Wednesday, February 7th. So we're going to get this party started here and see how this goes. Let's start capturing a little bit of footage. So this is my work area. You can see I got a few things here. This is behind the scenes work table in the back of our shop. I work on a various number of items, whatever comes through the door, and it's a wide variety of things. But we're going to start off on this and get it going. So we still have a couple other things to take care of first, but I may not be talking the whole time through the video, but we're going to let y'all see it, how it's done step by step as we go. Okay. All right, so I got the plastic and the box off of these things. There's some things you won't see in here, like who we get our parts from and our vendors and stuff like that. So I'm not permitted to show stuff like that. I mean, sometimes you might get a glimpse of it. It's probably not my fault, but I'm not going to sit here and show you all the packages and stuff that we get and where they come from and stuff like that. So, but what we're doing today is a 8V-92 Detroit. It's a natural engine, but it has a big bearing set. Small bearing sets are a smaller diameter than this for the blower, for the smaller blower. So, but now I got all that's undone. Let's go ahead and get started with our rotors. What we're going to do is going to remove the old wear sleeves off the end right here, off of both ends, and we'll install some new wear sleeves. We're going here for our seals. So yeah, keep a wide array of stuff here. These things are very simple to remove. Oh, and this is in case you wondered about the other bearing types, this is the small bearing type compared to the big bearing type. This is for your standard blowers. These blowers here are for the 92 series, which handles a lot more torque power and also is good for turbocharged engines. But usually if we go with a turbocharged engine, we end up going with a big bearing type. So the small bearing type is just your standard, air-blown engine. Because the TI turbo intercool type has blowers and turbochargers. So they try to ram as much air as they can into it to give as much power as they can. But they tend to break down under that stress, but it is what it is. But that's the way that Detroit designed these things back in the day. But small bearings, big bearings. So today we're building a big bearing set. All right. Got that. Now these right here are usually brittle, and usually you just hit them and they'll snap. They just break in half, and you can get them off of the shaft. That's all it is. Sometimes it takes a little bit for these things to move, and they'll crack, and you can get them off the shaft like that when they crack. But you can see what a seal and we'll run into it from the previous use. It's a double-lit seal for turbochargers. But we'll get into that part here in a little bit. Our installation kits are not always up to standard. we do have homemade tools that benefit us better than original shop-made tools. So it's whatever suits our needs. We don't always use, like this right here, Snap-on. We don't always use name brand tools. They're just too expensive. So don't ever think that hype about, oh, we gotta have Snap-on. Oh, and ignore my co-worker over there. He's over there singing to the radio. You hear the radio in the background. It's a radio station that's not too far from us. It's called KMRC 92.9. It's Louisiana's Cajun Swamp Pop music. So if you want to listen, go to their website, KMRC.com, and tap on the little dog paw on the screen, and you can listen along to what we listen to. It's South Louisiana Cajun music, 24/7. 92.9 KMRC. It's not that I'm advertising for these people, but we hear it every day, and it plays here every day. So that's what we do. So we're putting a little bit of gasket sealer on the inside of these wear sleeves, so the oil doesn't seep under the wear sleeve. And sometimes it'll seep under the wear sleeve when you get under enough pressure. We want to make sure that our wear sleeve is on the shaft at the right depth. We'll take our gasket sealer, we'll wipe it off, and we'll leave a little bit of shoulder, a little bit of lip right here. So when we use our installer here, and it goes through the housing, said like this, it fits in the shoulder right here, so we don't mess up our seal when we put this in the housing on our wear sleeve. It's the same diameter, but that's what those are for. It's not too many YouTube channels that's going to show you the extent of stuff like this. They're not gonna build it start to finish. This video may cut. Depends on what I'm doing, depends on what I get called to do. This is not the only thing I got going on right now. I got 19 other jobs going on currently. Waiting on parts. I got stuff cleaned up, got stuff backed up. Wipe off the excess so it doesn't get in our seal when we put it in the housing. Ignore my guy over there, he's being crazy, singing to himself. And again, you see the little lip there, and that accommodates that right there. So you have the right, when we put our lip seal on, it doesn't damage it. Okay. Now I'm going to install the lip seals here. Use of a 1x4s made into a little block. We have our tools here. Now as for shims, you know, you're going to have some people that's going to watch this thing, they do mechanic work, and they're going to say this, they're going to say that. There are shims that's needed in the shafts in order to get the rotors the right clearing from the edge of the housings, and I'll show you that when we get to it. But the shims on this has already been pre-done. We already know where it's going to be. As many times we get blowers back sometimes that we've already worked on in the past, and a couple years later or many months later they'll come back to us, and we already know.
Missed you guys.
Hold on a second. Okay, pardon me, we're back. Had to accommodate a customer. He come to pick up some fittings for a Caterpillar fuel transfer pump, and had to get with him for a second. Okay, so we got our seal on here. When we put our seal on the installer tool, you want the flat side against the tool, concave side toward the other inner housing. This is your rotor side, this is your dry air side. So we want the flat side to seal to the dry side. Camera angle is kind of bugging me here. Okay. So we're going to install this because this is going to be the oil side. When you're going to do the oil side, you want the lip on the inside, the oil side, face up toward the gear. Okay. Make sure we're nice and squared off. A little bit of a pound. We'll take off the lip support. Put this on the tool. Make sure you don't mess the lip up. And there you go. That's how it is. It's a little bit of countersuck so it's not in the way of the rotor. Doesn't get hit. And then we should have a little bit of excess stuff on the inside. We'll make sure we wipe that out. Clean it out so it doesn't get in our bearing or our seal. A little precaution. And we do sandblast our parts. We do have an in-house sandblaster. It's an enclosed cabinet. And all the parts that we sandblast are thoroughly washed and cleaned with mineral spirits of Varsol to make sure we don't have any sand trapped in anything. So we're very, very adamant about that. We don't like sending out bad products. So now we got that one done. We'll put it over here. Go ahead and we'll get the next housing done. Quiet. Take off the wear sleeve, the holder sleeve, and put it in just like that. This is what we're using. Gasket maker. Permatex. It's in the blue too, but it's a red paste. Works really well. It stays a little bit of gooey. It's not like the old brown Permatex. It gets hard. Makes too much of a mess. This stuff is fairly easy to work with. It's kind of tacky, but it's still fairly easy to work with. So we do it all here. We do heads, we polish crankshafts, camshafts. We're not able to check connecting rods yet. We still send those off to another vendor in order to have them checked and trued and redone. We just don't quite have the machines here for that. But as for like automotive blocks, we do automotive, we do diesel engine stuff, we do a lot of stuff. If it ever comes through the door. Manifold shaving, head shaving, injector tubes for Detroit, Caterpillar, stuff like that. We have rotary hot vats. You can put a whole engine block in it. Rotary hot vat it. But we have one for steel and one for aluminum, so we don't mess up our aluminum parts. So yeah, this is my world. 8 hours a day. Got the wear sleeves on one rotor done. Do the wear sleeves on the second rotor. Not quite. Okay. That one come off. Okay, that one broke. That one comes off. Have a scrap metal trash bin under my table. So that one's brass, aluminum, and iron, brass, and iron, aluminum, and brass. Keep the metal separated because the company owners like to go sell scrap metal once in a while, and makes it much easier when things are separated. On my end, install the sleeve. And this right here, just to make sure that we don't have any oil seepage under the sleeve. And these things run at high speeds. They run at some pretty high speeds. Yeah, they run at some fairly high speeds. And the blowers always turn a lot faster than what the crankshaft does. So, don't ask me rated horsepower on stuff. I'm not, I don't know the rated horsepower on a lot of engines because they make so many different variables. So many different horsepowers and stuff. I recently done a fuel system for a 3412 Caterpillar. Come up pretty nice. I think about it. I'll get the picture off my phone. I'll send it to you. I'll send it up, put it up on this video. Make sure we wipe off that excess. This right here has a different type of spline. It's an inner spline because it's the drive for the governor. The governor regulates the fuel on the fuel rack that regulates the injectors. Okay. You'd have to see it, how it works. It's a bit crazy, but it works. Works very well. Okay, let's put that here. This is the bottom side. This is the top side. So these blowers the way they are, the block, you can put a cooler underneath of it inside the block. That's called the intercooler. And your aftercooler can go up here after your turbo, and it cools the air from the turbo into the blower. These blowers can take a limited amount of heat, but not too much. So you got to be careful if we do a turbocharged deal. So, but that's what the decking is for, and the extra holes. Otherwise, your normal air intake would just bolt on to the 6 3/8 style holes. These here are for your turbocharged outfit. The 92s have that. Some of the 71 Detroits have it, but it's basically the same blower. It's just you can outfit it for a 71 if it's a turbocharged engine, but that's a special application. Okay, so now we're going to get a little sealant going on. I'm going to put a little bit of sealant around here because this plate has no gasket. It's just going to seal on this face. And make sure we don't get any in the rotor area. All it does. It's just so air pressure doesn't escape whenever you're running a plate. And when you're installing something like this, you gotta watch. So these two plates are different because this would be your rear plate for your drive, your gear drive to come into. Because of this hole here, you can see it is threaded. And that's your oil supply. If you notice on this would be the front plate. That hole is there, but there's no threads, and that hole doesn't go all the way into this gallery. This gallery right here is where it squirts oil out right here in order to lubricate your gear system. And then the holes here at the bottom, can't really see them that well. And there's a hole that right here, when your oil level gets to here, it just overflows right here and goes back into the engine block. And it does it on both plates, so you don't overfill these areas. So So what we're going to do, we're going to install the rear plate on here. But you can see it's lined up by dowel pin. You get dowel pins that line it up on the housing so it stays centered and true. So what we're going to do, we'll put that there. Then I get our love tapper. I'm just going to make sure that we are tapped up there. My guy over there singing along again. All right, second here. Let me grab never sees. We'll get a little anti-seize. And we're going to put in these cover screws. These cover screws are only here to hold the cover on for assembly. This is basically all it is. Just a little screw, 5/16 diameter, regular flathead. That's all it does. Just goes in those holes, just to hold the cover on for assembly. When the next cover is put on over the gears, then that holds the whole plate down on the housing. These two are only for the assembly. People torque these things down and tighten them up to no end, and there's no reason for that. All you got to do is put a little anti-seize on them and just run them down with your screwdriver. That's all you got to do. Just snug them down good so they stay flush on the housing. That's all it takes. Okay. Now, I'm going to lay this down. Now to deal with this, we have to watch our rotors. Make sure we get our goop off of there. We don't want it getting in our bearings or in our seal. You notice this rotor here has a spline on both ends. Okay. Certain splines are there for a reason. This rotor here is a spline on one end, but it has an internal spline on this end for a governor drive. You go to certain areas, depending on which rotation you have. Actually, the rotation stays the same. It's just the way the gear train is set up different for left or right-handed engines. Okay, you'll notice you have a big groove here. One spline is bigger than the rest. That one spline has to be lined up with this lobe on this rotor. You notice on the other side, that one is not lined up with a single lobe. It's off. This is your fuel pump drive side. So what we're going to do, we are going to put on our stabbing tool. You see our spline. That is going to go on the left side. And it's going to stab in the hole back here. And it does, it comes out like so. Like this. So it goes through the seal without messing up the seal. So we're going to hold that. That's going to stay. I'm going to get our second rotor and find the direction of our spline. Now, both splines have to face the same way. So the one on that end is facing left. When we're going to put this spline in, it's going to face left. Just like the other one. If they don't match, you can't time your gear set right. If your gear set's not timed right, you're not going to be able to put your blower together because it'll bind up. So you have to find out where it's going to sit. And then you just put it in. Aluminum seems to grab on everything. Goes into our seal. And you push it on in. Now, we'll take this off, and we'll notice that both of our big splines are facing the same direction, and that's what we want. So what we're going to do now, we're going to use some 5 spacer standoffs. And the standoffs are put in as legs so we can stand the blower up to put on the other end plate, so these 2 shafts don't fall out of our seals. And that's what we're going to do. All right. Barely snug them. And we're going to stand this up. Now we got to set up. We can work on the top side of the blower. And again, so what happens is, this is the bottom side. There's a plate that goes here with a governor housing. The governor housing drives the speed and controls the rack, the injector rack. My guy over there, he's crazy. He's funny though. Actually, our shop foreman, but we work the back section of the shop. There's a couple guys that work the front section of the shop and take care of most of the automotive stuff and heads and valves and other stuff like that, shaving and machining and stuff like that. Okay, so now we're going to take our 2 spacers, put them in like this. Then we'll take our other plate, put it up. See, it's sitting on a seal, so we're going to make sure it's all the way down. We're going to pass it down. Tap it down easy. And we're going to come over here and get our other 2 screws. We're going to put anti-seize on these screws because these engine components are usually exposed to saltwater environments. And when they come back, they get so corroded and messed up, it's rather difficult to get these things apart sometimes. So the same. We just tighten up these covers. That's how it is. So now your rotors are encaged. Your timing is already set. So your gears only go on one way. What we're going to do, we're going to go ahead and put in our bearings for the front. If you notice on the bearing, it has a little sleeve on the inside. So you put these on as a set. Okay, so the sleeve goes down like this, just like that. And that one goes to the governor drive. We can lightly tap it to start it. Okay. So these right here are flush on the race. They're flush races. On the 71 series, the center race is countersunk. So these are flush races. Put those on our shaft. And we're going to use a flush race installer. This is this one. It's just a flush race. On the 71 you use this one because it fits the bearing for the countersunk race. But we don't have countersunk races on these bearings. So it might seem a little harsh And this is what we do. Till you hear solid. That one seemed to have not quite gone down all the way. Yep, it's not quite gone down all the way. There we go. Now we're done. We'll countersunk just a little bit. And that is hence the purpose of these pleats. They hold the bearing down in the countersink. And these pleats here hold down the bearing in the rear pleat. So you'll see these countersink like that. And they screw down. So we'll go ahead and we'll get these in place. And we've got these little, they use the little screws. You'll see that's a Phillips head screw, double. But we're going to put a little spot of Loctite on these things so they don't back out when we install them. My God, that's crazy. We have a lot of fun at work. If you can't come to work and have fun, don't go to work. It ain't worth it. We come to have a little fun. We also come to do our job. But anyway, have a little fun. Let's see if I can find my Loctite. Ah, here we go. Here's my Loctite. Now, by no means am one of these professional YouTubers. See? I drop stuff all the time. Then we're gonna get a little screws in here. Run it down just before it gets to the bevel. Little small amount of Loctite. When you're working on something like this, make sure you clean all your parts thoroughly. Run a tap in all your holes, make sure everything's good to go. It makes the assembly so much better. Once you get all your screws in, just thoroughly get a real good grip on it, just tighten it down. There's no need to kill it. That's all it's going to do. When the Loctite sets, it should be good to go. So let's see, we'll put a little blue. A little bit much, so we're going to put a little bit on this screw too. Okay. We'll start that one off. Start that one off. Get your plate center up, where you pull it all the way down, according to your bevel screws. So you don't have any issues. You tighten it down by hand. In the disassembly, you can use a little small propane torch in order to warm it up to loosen up your Loctite. Because sometimes that Loctite holds pretty good when it's dry. Okay. So that's that side. What we're going to put in the fuel pump drive, which is going to just go in here like this. just a sleeve. You get a washer that goes in it like this, and our fuel pump has a bullhorn that fits there. Let me see if I have one real quick right here, and I'll show you. Yes, I do. So this is a drive off of a fuel pump for Detroit, and that bullhorn goes on the back of your fuel pump, and then it fits in your hole, and it goes into your drive like this. And as your engine turns, well, it turns your drive. So that's how that mechanism works. But yeah. So yeah, we put, and that's all it is. It's just this. You put that in there, just spin. There's nothing to hold it until you put your washer. And then you put. That guy gotta be drunk. He's nuts. Sometimes you got to be crazy to work at this place. This is what we're doing here. We got all the lock keeper on our bolt. Actually, we're going to use the shorter bolt. This one has two longer bolts for the rear gears, and it has a shorter bolt for the front. So we are going to put a little bit of Loctite here. And we're going to put our screw. Screw it down. And our star keeper is there. The little keepers go up, you see. I got one here. Just concave up one way. So you make sure you put this up. Then when you put your bolts and tighten it up, you can bend these on the ears up against your head of your bolt so it doesn't unscrew. And it keeps it locked down. One of these tabs get knocked down and goes into the groove for the fuel pump drive, so it doesn't unscrew, makes a self-locking nut. So let me see here. We can get a small punch. And we are going to knock this one pin down. Going to do, I'm going to lay this down before I bend the tabs over, so one shouldn't move. We are going to put a rag in the blower. The tolerances are very tight, so we can put a rag in it in order to torque down this bolt. It's going to be a 3/4 bolt, and we're going to torque it down at 80 pounds. You do not want to get your fingers in the rotor when you're torquing this, because you will get them cut off. Okay, so now we're going to put 3 shim standoffs here. Actually, I can put 2 stem standoffs. Let me use this bolt as my 3rd leg. Instead of using 4, we'll just use 3. Okay. So now we'll stand this up. And we'll stand like this. We'll take out our standoffs. Pardon me if some of this, oh, I hit the camera. Pardon me if some of this gets loud. And we are going to put in our large bearing sets. It doesn't matter which way they go, they can go in either way. But the large bearing sets are much more heavy duty, and it's for the drive in, because it's the one that can handle the torque pressure from the drive. So it's a lot of, it takes a lot of beating. It takes a lot of beating. Okay. Now we're going to put on, oh, I got gasket junk on my camera. Hold on a second here, let me get that off there. Okay, there we go, we got it wiped off. And we're gonna put on the rear end keeper plates. The way you think to cut, you gotta watch for the bevel on the inside for the screw. One side don't have the bevel, so you gotta use the beveled side to put your screw in. So that faces outward. So we have our little screws. We have our shims. We do need some shims for this one, and we'll get into that a little bit. So we'll put a little bit tight on our screw. A little much, put on another screw. We'll share. Yep, my butterfingers dropped it again. That's good, got it right there. I'm not going to disclose the company name where I work at. Eventually in time it'll come across. I'm not going to openly advertise it, but you'll see it. Just keep watching the videos. Comes and goes. Pull down on screws so we get it squared off of the plate. So yeah, just got to make sure that this is your rear plate, because this is your oil feed because of the threaded line. That's your oil feed. And what it does, this feeds in from your rear gear train housing. The bell housing feeds into this. The front side is fed from the engine block, which are both fed from the engine block, but it also feeds through the bell housing, because this is your gear train side, your gear side. So it takes a lot more beating than the rest of the engine. Why get up? Okay. Usually these blowers come with end plate covers and different drive assemblies. This particular customer sent it here like this with just a gear assembly on the back, and that's the way that the customer is going to get it back. We only repair it to what they send. We don't add extra features unless they request it or pay for it. That we'll make sure that this sets tight. It is, and our Loctite is already set, as you can see. So now we have right here 47K on the dry side, 47K shims, which we're going to measure that to make sure. We are going to measure that to make sure. 47 thousandths. Yep. 48, 40. Yeah, 47. 47 thousandths on shims. So now, we're going to see what shims we have here. 40,000 shims comes in this pack. have a few new ones here. Shims come in 5s, 10s, 2.5s, and 1.5. $40. $5. So we need 2,000. You can go with a 2.5. 2.5 would work. That's a 5. That's not. What is this? These two are very thin and flimsy. This would be 3. So we can go with that. And this should get us where we need to be. It's just because these engine parts have been built and rebuilt so many times. They just get wore. They just get wore out. We have 2 pre-made shims for the 92 series. They're the only ones that have it. The 53 series does have it, but not quite like this. Okay. So when I spoke about the splines being in one area, the reason for that is the gear has the one spline in the same area. So our drive side is going to be our, at the bottom or the back, will be our right side. And you can see in there, it has that one spline. We got to make sure that our splines are lined up. You can't see it, but I can. I got to mark that so I can see it from the top. So put me a pin mark there so I can see it from the top when I put the gear on. I'll work on getting the camera on a tripod later on so I can get a top view. Not today though. This is just a trial. Until we get our stuff situated. Okay. So yeah, you can see in there, you see how the spline lines up on the mark that I gave. And that's going to be the same with both sides. And the gear presses down. The thing about these gears, they both have to go on evenly, both at the same time. They have to be pulled down. So you have to make sure that your splines are right. And you have to seat evenly at the same time. Both have to go down evenly. Now we can put in our washers for now. We'll put in our bolts. And these will pull our gears down. Let me grab the socket off the torque wrench. And we'll come over here. And we will get our little, yeah, we do have snap-on tools. Some, not all. Use whatever fits. We're going to pull this down. You see how your gears are offset? Because they got to be pulled down together. You can only go so much. And you can start to get snug and you pull the other side down. Don't pull these down with an impact. Pull them down with a wrench, where you can hand feel everything. You pull down with an impact and you get something in the vine, you don't realize it. You break something or bend something and it just won't line up right. So do it correctly and it'll always come out right. It'll come out like it's supposed to be. And once you got these pulled down in place, You can see that our blower turns like it's supposed to now, because now the gear sets have put it in time like it should be. Now my gears are pulled down. I am going to turn this around, lay it down. Just a moment, please. Gotta answer a phone call. Okay, come back. Yeah, I had another customer call me just now. He needed information on another part. Sorry about that. Let's get our top back on our Loctite. We're gonna need it again in a little bit anyway. Okay, we're going to throw a rag in the top of this thing. And when you get this thing together, you hear that. You have a little bit of a gear lash between the two so the gears don't mesh together. And that's where you want to be. You want to have a little bit of a gear lash. So we're going to torque these down, and then we're going to check our clearances with a feeler gauge. These are also going to be, not going to really torque these down a lot. Just going to snug them. And we're going to check our clearances to make sure we're good. And if it's good, and then we'll come back and we'll torque them down. So on our feeler gauge sets, this is a lot of handmade specialty tools, stuff we use for different diesel engines and fuel systems and seal installers and other kind of stuff like that. Okay, so kind of rule between the rotors where they mesh together. Where they mesh together on the inside, you can see it here. Man, don't ever get your finger caught in that thing, because I tell you, it's unforgiving. You only have 8 thousandths clearing inside, and you only have 5 thousandths clearing under the edge. And you see it right there. There ain't no way a finger's gonna survive 5 thousandths of clearance. It's definitely not. You'll be going to the emergency room to get it sewn back on. Okay, so our feeler gauge, we're gonna bring in the 8 thousandths. We're gonna run it through a vein. Okay, as long as it don't bind up, we should be good. And when it meshes together, we can still pull it out. And you can pull it. You can still pull through your veins. Let it suck it in, and you can pull it. If you can't pull it, then you messed up. Rule of thumb on blowers is, if it's too tight, add a shim. If it's too loose, take away a shim. I know it sounds backwards, but that's the way it is. It all depends on the way the gear delivers the height off of the end plates. You know, the height on the end plates. Which I'll show you that here in just a minute. So now we're going to go to for the feeler gauge. Our depth is 8 to 12. And I usually go with a 12 right off the bat. Because if I got at least a 12 clearance, we can go a little bit over a 12, which is okay. But if we can get a 12 in there and it's a little snug, you'll see it back here. If it gets in underneath that lobe right there, and it gets in underneath that lobe, which is good. And right here, if it gets in underneath that rotor, see, that's good. That's a 12. And this one here, that's a 12. Okay, so we're good on that end. We're good on the 8 thousandths in the middle. So now we're going to check rotor clearance over here. Okay, my 12. You can see it, my 12 goes in. And then right here we'll check the other rotor. And my 12 goes in. It's a little bit tight, but it goes in behind that, between the wall and the rotor. So our clearances here are good. Now, on the top side, actually you have probably about 8 thousandths clearance on the top right here. Okay, so you have a little bit more clearance there. It's not too bad. It's fine. You can go probably like 15 or 18 thousandths. On the bottom, when the rotor comes in, This right here is going to be about 5 to 7 thousandths on this clearance. So you don't have too much right here. This is on the bottom side. As for the rest of our clearances, we are good. Some of our clearances on here is going to be a little more, a little less, sometimes what we like, but we can't change that because the housing and the rotors. I mean, this blower could have been rebuilt 20 times already, but nobody knows. We do keep track of some of it, but we don't keep track of all of it because it's not always us that does it. This blower could have been rebuilt by 20 other vendors. We don't know. So now what I'm gonna do, I'm gonna get my rag back over here. I'll put my rag back in my rotors. Get it down in here. Now I'm gonna take my bolt off. Yeah, it tends to be a little tight. This is the reality of it, man. No, it's not going to be easy. Stand here at the table for 8 hours a day, 5 days a week, and rebuild components. So what we're going to do, we're going to get our Loctite again. We're going to get a little bit of Loctite in it. Use a blue Loctite. Don't use red Loctite. You either use red Loctite until you get everything away, because you never get it out. Blue Loctite just holds it. Red Loctite, it's game over. We don't use red Loctite. This is what we use. 242 blue. Yep. Use red, the thing is done. Now the other one that we use is, it's a Permatex. It's a gasket, so it stays kind of gooey. It never really hardens up into a Loctite. It is red though. So here we're going to put a little bit this one as well. It's aluminum. It'll be all right. We ain't gonna break it. This thing takes a hell of a lot more beating than what I could put on it, I tell you. Now, this is gonna be a little tough, so bear with me. £80. You don't have to be crazy. Now when the customer's going to get this back, he's going to put his own drive assembly on it, and he's going to put his own end covers on it. And we can, and you hear that? That's the gear lash that you want. That way you can get oil between your teeth. Okay, so that's, there we go. So when you turn your gear train in the back, run your fuel pump drive, there's your blower. That's it. Be extra careful. Don't get your fingers stuck in the gears or in the rotors. And it'll be good. Okay. So that's going to conclude our build of this blower. Thank y'all for watching.